Okay, this is section 3.2 about stretches and shrinks. We're taking functions and we are going to stretch them. So the function is made up of a whole bunch of points and you just connect the dots, right? So this spot right here is 1, 1. That spot right there is 3, 1. This spot's 2, 0, etc. Okay, what if I wanted to move this thing up 1? That's a move. We've already done that. That's like old stuff. It'd be super easy to move it up 1. But what if we were to stretch it? What that means is you can either stretch it or shrink it. When a number's on the outside like this, just like the number on the outside at the end, we could always trust it. Remember the stuff on the inside is what we couldn't trust? So, since it's on the outside, we can trust it. So if this seems like it's half as tall, because that's on the outside and that's an up-down thing, and therefore it's talking about height, this would mean half as tall. Just like it looks. You can imagine if I put it on the inside, you know, if I put the little 1/2 right in here, then it would mean not half as tall, it's half as wide, but then you have to say, wait a minute, I'm on the inside, so it's not really half as wide, it's really, what do you think? Twice as wide. Does that make sense? Okay, so this one's on the outside, so it's an up-down thing, so it's going up or down. It's going to stretch this thing half as tall. Does that make it stretch or shrink, technically? That shrinks it. All right. So if I'm going to shrink this thing, it is so easy to do with just a picture. You can take all the heights and make them half as high. This has no height. If he's 0 tall and I multiply him by 1/2, he will still be 0 tall. This height right here is 1, so it's going to be half of that. And I'd like you to quick sketch for me what you think the thing looks like if I make it half as tall. Go ahead and sketch it on your iPad and show me. All right, 2 people have it right. Good. Yep, that's it. That's it. That's it. That's it. Yup, 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 yup. Okay, pretty much everybody's getting this right. It's good. So it's half as tall. Now, how do you do that with the points, though? Well, now that you can look at them, it wouldn't be that hard to see it. Say, okay, the parent points were 0, 0, 1, 1, 2, 0, 3, 1. And the new points are, think about this, from the points perspective, did their x's change at all? No. So all the original x's are the same. And of course, this is an xy chart with the x on the left. The x is always on the left. So then the 1/2 f of x, all the x's stayed the same. So 0, 1, 2, 3, and 4. Now last one's 4, 0. Now the y's are the rise, or the height, right? The y heights all are half as big. But if you had a height of 0 and you go half as big, it's still a height of 0. Now this one we had a height of 1, and now the height is what? Come on. Half of that. And now we had a height of 0, and the height is still 0. And then the height was a 1, and so now it's a height of a half. And last one's 4, 0, so it's still 4, 0. Okay. Could you have just copied that off the chart? Yeah, but that's not the point. You should be able to think it through. All right. Would you agree that in this last one, if I'm going to make it twice as tall, that the x's are not going to change at all? Okay, so then 0, 1, 2, 3, 4. There's my 5 points I would have. Now let's not even draw this one. Let's just make the chart for it. If the x's aren't going to change at all because it's getting twice as tall, the y's are all going to change. Go to the original, though. Don't go to the one we just shrunk. Go to the original one and look at their heights. And what did I do to all the heights this time? Times them by 2. All right, so if it was 0, 1, 0, 1, 0, now it's going to be 0, 2, 0, 2, 0. That make sense? Okay. So all we just did there was take all the y's and multiply them by 2. Think about this. You see how there's a 2 being multiplied by the function? And y equals that? So it's just whatever y equaled, now it's twice as big. It makes sense. Okay, so then now, make a quick sketch of it. This is stretched twice as tall. It's not too hard to do. Yep. Yep, yep. Yep, yep, yep. Yep, yep. 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 Cool, you can keep going with it though. Yep. 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 Yep, yep, yep. Okay, good. People are getting this. So it's twice as tall now. That's it. Okay. Take a guess what we're going to mess with next. The x's. So we just changed all the y's. What if we wanted to mess with the x's? That's going to be something on the inside. I want you to erase all of the ones we did already because that's going to get too messy. Go back to the original. Okay, just erasing this area. Now, imagine for a moment that I wanted to make this shape twice as long. Actually, you know what? Maybe there's a slide for this. Yeah, I'm going to go to the next slide. Sorry, made you erase or nothing. Next slide has a spot to do stretches on the inside. Okay, now think about this. Seems like it's half as wide, or it should seem like that to you. But it's actually what? Twice as wide. Go ahead and draw what you think it should look like if it's going to be twice as wide. A lot of people mess this one up. It's harder. Yes. Nice job, KD. You only did part of your shape. The rest of your shape needs to be done. Yes, sir. Yes, that's correct. Yep. 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 I see yours in the blue. I didn't see yours. Yeah. Yes. Good. Yes. Yes. Some of you haven't shown me yet. I'm waiting. I hope you're not like playing doodle jump. Okay, you have the good, except you need to finish it like it needs to go all the way. Yes, yes. Back corner, haven't seen. Did I already see yours? Okay, second from the back corner. All right, good. All right, slide it. Yes, good. All right, good. Okay, people are getting this. It's just twice as wide. So if I were you, I'd say, how wide is it in the first place? 4. And I just double that and go, okay, here's my ending point. All right, it's got to be twice as wide. And then I can take each point and move it. This time the points are here, 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 and here, just like before, and I'm going to move them this way. Do you get that point at the end there? 4, 0 turned into 8. And then I can take this point and double its width. How wide was this point right here? Stay with me. How wide was this point right here? 3 wide. Now it's going to be 6 wide. So see, this point moves over to here. Okay. And now I take the next point, and this guy right here, he was 2 wide, so he's now 4 wide. That's going to be a little complicated because it's on top of another one. But all right, so there's a spot. And now this one was over 1, see, to here. And now I'm going to make him twice as wide. And then you just have to connect the dots. Okay, good. Remember, the only thing that's hard about this is the fact that it's counterintuitive. If you see a half on the inside, don't make it half as wide. Make it twice as wide. All right, I don't think we need to do all of those points and everything. Here's the random function. So that means if I was writing this function, I'd throw an f into it because I don't know what it's called. It's not absolute value. It's not square root. It's, all right. Now, is it a function? It just needs to pass the what to be a function? Vertical line test. So it's a function. It only touches once. Right in there, it's a little iffy because it almost looks like there's a straight part. And same in here, and iffy. But we were trying to make this a function anyway. Okay. So if I'm going to take said function and do this to it, XY chart, then look at what happened to it. Are we making it taller or wider? Are we messing with the height or the width? The height. And in this case, it has a half, and can we trust that? And go half as tall? Yes, we can, because it's on the outside of the function. So it's half as tall. Would you agree that the x's then, if we're only going to make it half as tall, the x's are not going to change? All right. This is the most important part on this. You need to write down the parent points. These, and maybe even that's kind of an important point. If you want to do more points, you can always do more. I'm going to include those 1, 2, 3, 4, 5 points. And I'm going to put them on an XY chart. So the parent points are negative 3, comma 4. Please make a chart with me. Negative 1, comma 1. 1, comma 3. 3, comma 1. And 6, comma negative 3. So why is that helpful? Because now half of my job is done. For this function, I already know that the x's are not going to change because I'm only messing with the height, and that's the y's. So the x's are all going to stay the same. Sorry, 1, 3, and 6. You can copy those over. And now, how about the heights? Should I trust it and multiply it by a half just like it looks like it is? Yes, because you can trust the stuff on the outside. So I make it half of what it used to be. It used to be 4, now it's 2. It used to be 1, now it's a half. It used to be 3, now it's 1.5. Used to be 1, now it's 0.5. And that's the same as a half, of course. And it used to be negative 3. Ooh, be careful with the negative. Now it's a negative 1.5. Now guess what happens if you graph your points? The shape will do what? Shrink. Now some people just think it moves down. No, this point here is actually going to move up. We're not doing a shift down, we're shrinking the shape. And that means it used to be down 3, now it's going to be still down, but it's going to be down only 1.5. See, so it's shrinking towards this axis in both directions. All right, so let's graph those points that we just made. Use a bright color so you can tell it away from the black. Negative 3, comma 2. Graph all the points we just made. And then show me what your result is. Please do zoom it in. Awesome. Yep. These are a little more subtle. It's hard to see. It's not just like, oh, I have an M and the thing's twice as tall. Because there's stuff above and below the axis, it's a little more weird. Yes, that's it. You got it. Yep. Hardest part to do right is that little circle. Yep, good job. Yep, that's it. Yep, that's it. Yep, okay, I'm seeing enough people getting it. I think we're getting it. So I'm going to make this half as tall, that half as tall, that half as tall, and that half as tall. And I go down, then this part's the hard part to do nicely. And then like that. Okay. So I made this shape shrink and become half as tall. Notice its width is the same. The width it was is still the same. People think shrink, they try to shrink it in all directions. That's not right. We're only shrinking these in certain ways. The width has to stay the same on this shape. All right, I think that's good enough. I think you're getting this. So now let's move on to the green shape here, the green slide. And do the second one on the green slide. Do it yourself. Do it without my help at all. And I encourage you to start by figuring out the parent points. There are 2 parts to this. One is the actual picture that you make, and the other is the XY chart of the new function. Both are worth points. So if you're stuck on what to do right now, you should be copying down those parent points. Negative 3, comma 4 is your first parent point. I'll pause for a second while you're working on it. So to keep from having to pick on any individual in particular, I will roll a die. It gives me the 4th row. 1, 2, 3, 4th row. Somebody in this row. Then, from the front, the second person from the front. Now I have a choice. I could make that you or you. It's because this is the first seat. But I think it's second person. So, back to you. Would you please project up to the board with the reflector? Because I happen to already have you logged in, which is perfect. Random chance comes through for me. And now let's see if she did it right. Now, it looks to me like her shape is wider than it used to be. Is that supposed to have happened? Think about it. Is the stuff on the inside wider stuff. Yes, it is. And remember, there's a little saying, I haven't used it very much, but I'll remind you right now, hi-vo. Do you know what I'm talking about? Like, hi-ho, it's off to work we go. Anyway, hi-vo, I'm going to move this. Can you grab your iPad? Actually, I can do this. Slide it over like this. Hi-vo. Horizontal on inside, vertical on outside. That'll help you remember, as long as you know what horizontal and vertical mean. Horizontal is like horizon, so horizontal moves are like this across the horizon. Okay? And vertical, and if you have a great vertical leap, that's an up and down kind of leap. All right? So horizontal on the inside. Is this on the inside? This little 1/2 we did? Yes, it is. You can say things like yes when I ask you a question. It's not a really hard one. Okay. Is this horizontal on the inside? Use the voice muscles. Yes, it is. Okay. Is this to be trusted? No, because it's on the inside. So it seems like it's half the width, but in fact, it's twice the width. So yes, you generally did it right. Now, let me take each of your points and see if you actually made them go twice as far. This one used to be over 3, the one right there, the little pointer is. That one used to be 3, now it's over 6. Yay. It used to be over 1, now it's over 2. This point here used to be over 3, now it's over 6. This one used to be over meaning like from here to here. It used to be over 6, and now it's over, your best guess, to where 12 would be. Awesome. Very nicely done. Raise your hand if you agreed with her and had this correct. Okay, good. Can you unmirror this for me, please? Awesome. And then this is just a reminder that your stretch or your shrink, the number that's in front of it, okay, this B, or the number that's inside it, if it's a stretch, that's between 0 and 1, meaning like a decimal, like 0.5. Because on the inside, if it's a 0.5, it's counterintuitive. Seems like it should be half as big, actually twice as big. And if it's a shrink, it's the other way. And of course, if it's on the outside, you can trust it. If this is a stretch, it will be bigger than 1 out here. All right, I think to me, some people learn from reading better than from me explaining. So I'm happy we have these slides in here, but I did tell you this in words already. So, okay, take a look at this one. All you'd have to do is describe what's going to happen. This is a common, like, people like, what does this divide by 4 mean? Wouldn't you agree that's the exact same thing as 1/4 x? X over 4 is 1/4 x. If you hadn't learned that before, learn it now. Because that'll remind you, okay, is this look to you at first glance like I should make it smaller or bigger? Smaller, but you don't trust the stuff on the inside, therefore it's bigger. And how much bigger? 4 times. So this thing will get 4 times wider. Now officially, if I was talking wider, I would be talking, is that horizontal or vertical? Horizontal. Okay, so that would be a horizontal, and I'd accept the abbreviation of an H. And is that a stretch or a shrink? And this is important. Stretch. You have to say those words, horizontal stretch, otherwise you won't get it right. Just like I was just saying things like left, right. It's good for you to understand left, right, but really what's the official word for left, right? Horizontal. Okay, so you learn the right words to say. All right, this next one. Is it horizontal or vertical? Horizontal. Is it a stretch or a shrink? Shrink. Seems like it's going to be a stretch, but then it's the opposite of that, so it's a horizontal shrink. And the last thing we need to learn is how much of a shrink. You can't say it's a shrink of 3. You can say factor 1/3. That's another word you need to start using. The factor, it's the shrink factor or the scale factor. All right, this one. Why isn't alone? You should not make any judgments until y is alone. So how do I get that divided by 2 off of there? Multiply by 2. And if I multiply by 2 on both sides, that one's going to go away because it'll cancel. And then timesing this one by 2, I'm going to happily put it right in front because that'll make it easier to understand. Oh, so this has actually 2 things going on. The negative, which you already learned, is a flip or a reflection. It's on the outside, so it's an up-down reflection. That can teach you that it's over the x-axis. So it's a reflection over x. Now this 2, can I trust that 2? Is it really twice as whatever? Yeah, it's on the outside. So it's twice as what? Wide or tall? Twice as tall. So this would mean a vertical stretch factor 2. And this negative right here is a reflection over the x-axis. It's an up-down reflection. Could I have said a vertical reflection? Yes. Vertical and horizontal are good math words. You can use them if you want. One thing to be careful of, if you're moving to the right, you better not say horizontal move, because that could be right or left. You need to say just right or left if you're talking about moves. All right, this one's the pièce de résistance. The big, amazing, culminating problem. Can you tell me all the things that are happening in that y equals? That's a function. It's the v shape. I can tell because it's an absolute value. So I would not use the mystery f. I would just call it absolute value. This is an absolute value that has been what? There's 1, 2, 3, 4 things happening. Try to list the 4 things. And I'm okay with you not doing it in the right order right now. Just tell me the 4 things. And then we'll talk about the order in a minute. Like, for instance, up 7 is in your list. All right, I'm not going to be able to read these very well, so I'm not going to ask you to turn it my way. I'm going to call on somebody. We'll make it a random person. Get your 4 things down, written down soon. Row 6. In row 6, person 4. You're person 4. Yes, you. What do you got for some of your 4 things? Left 5. Raise your hand if you agreed with her. Okay, awesome. Keep going. Up 7. How about that half? What's that? Shrink factor 1/2, but you left off for something really important. There's 2 ways to shrink something. Is it a vertical or a horizontal? Vertical. Good. So a V shrink would have been a good way to say that. And then the last part. And that's a flip, as an official word, is a reflect over what? Over X is correct. Good. Now, I'd like you to take those 4 things and renumber them. And you probably didn't put them in the same order she did. That was kind of a random order. I'd like you to number them now correctly. Like, this should be first, this should be second, this should be third, and this should be fourth. There is more than one right answer. I know that's always scary in math. Usually there's only one right answer. There's actually more than one right answer on this. Another confusion that comes from that is people say, well, but that means that there must be lots of, no, there's not lots of answers. There's only, I believe, 2, maybe 3 right answers for this. There's a lot of combos you could have that are not right. All right. Do you remember me saying start on the inside? But do you also remember me saying you should do all reflections first? Now, you can, that's the reason there's 2 right answers for this. You can start on the inside and it will be okay. Okay? You can start on the inside and do that left 5 first. That can be done. This is one possible order, okay? You might have a different right order, but I'm starting on the inside. Then I better get my reflections and stretches done next, which are these things on the outside. So those I'd like to give you a dumb little way to remember what should be first. If you're going to do a flip and you're going to stretch out, which should you do first? If you're going to do a flip, like a back flip, and you're going to stretch out, which should you do first? I think you know the answer. Stretch. So you should stretch before you flip. Okay, so I'm going to do my stretch, which in this case is actually a shrink, okay, before I flip. And then the last thing we do is that 7 there, which is the up 7. Now I said there was another way to do it, but that's one way to do it. I'm going to do my other way in red here. My other way would be, you said to do your reflections first. It's okay. You can start with the reflections, but now that we have stretches and shrinks and reflections are at the same level. They're both multiplies. So they both, if they're both multiplies, think about this math-wise. If they're both multiplies, does the order you do a multiply in matter? If I times by 3 and then times by 7 versus times by 7 and then times by 3, it doesn't matter. So you can do either one. But follow my rule of you should really stretch out before you flip. Okay? So I should really stretch before I flip. Of these two, this is the stretching one. This is the flipping one. Now that I'm done with those two, I only have 2 things left. And of the 2 things that are left, which are the 5 and the 7, is one of them better to do than the other? Generally, you should be doing the inside first. But you make this next and this last. I'm curious, how many of you had one of those 2 orders? Oh, that's about half of you. Good. All right. Okay, that is one of the toughest things is figuring out the right order. I want to spend some time on that today, but we really aren't officially spending much time on that. I just want to get you good at it so when it does happen, and it does matter, it's a hard topic. If I try to explain it to you the last day before the test, you won't get it. So I want to make sure I talk about it a few times before then. All right, that's all I need to teach you for today. I want you to pull up your assignment for today, and we'll see if you need any. I'm going to pause for a second. So here it is, stretches and shrinks, worksheet A.